So now lecture 6, and in this lecture I will give you an idea about the Nernst equation, with the help of which you can determine the electromotive force of a galvanic cell theoretically, that is using pen and paper and not with the help of an experiment that I have explained you in the previous lecture. Now, before going to the Nernst equation, you must know that where from is this electrical energy coming. In the first lecture, you have been informed that in electrochemical cell there will be interconversion between chemical energy and electrical energy, and in galvanic cell there will be conversion from chemical energy to electrical energy, and in electrolytic cell the reverse will occur. Now this chemical energy is giving you the electrical energy in case of galvanic cell, but in what form does this chemical energy is coming? So you have a chemical reaction, say R arrow P. You have a chemical reaction R arrow P that is occurring within the galvanic cell. Now the energy changes that may be associated with this reaction may be change in internal energy, that is internal energy of the product minus internal energy of reactant. It may be change in enthalpy, so it is enthalpy of the product minus enthalpy of reactant, and likewise it may be change in the Gibbs free energy, so it is product minus reactant. It may be Helmholtz free energy, so it is like this one. So there are several forms of changes in energy that are associated with a chemical reaction. So which energy is responsible for the electrical work that you obtain from a galvanic cell? That is a question. Now it is a common belief for several students and for the beginners or those who have not yet learned about this galvanic cell. It is a common belief that it is the change in enthalpy that is going to give the energy. Since this change in enthalpy is more familiar to students as exothermic and endothermic reactions. So in exothermic reaction, a reaction produces heat, and in endothermic reaction it absorbs heat. So an exothermic reaction can give you thermal energy in the form of heat. So that may be somehow getting converted to electrical energy. It is a common belief, but it is actually not so. This is interesting. It was Helmholtz who first identified that it is the change in the Gibbs free energy which is responsible for conversion of the electrical energy, so that what you get as an output from a galvanic cell is actually the change in the Gibbs free energy of the reaction that is occurring within the galvanic cell. So let us see how could he say that, because if he just say and we believe it, it is another belief system, so that is not going to work. So this is Gibbs free energy. What is this? This is a measure of ordered energy within a system. How it is? Now you know that H is the total heat content. So if you claim that it is a total heat content, then all the ordered energy and the disordered energy will be incorporated within this enthalpy, total heat content. So it can be roughly claimed that it is both ordered and disordered, total. So in a system, the total amount of ordered and the total amount of disordered energy will be accounted by this enthalpy. Now G is defined as G equals to H minus Ts. So what is that? Now S is a measure of randomness, and when it is multiplied by the temperature, what happens? It gets converted to energy. Now what energy it is referring to? Since it is a measure of randomness, and upon multiplying it by temperature, it will give you energy, then it must be disordered energy. So S is the measure of randomness, S is the measure of disorderedness within a system, and if you multiply this entropy by T, it will give you energy. So this energy obviously will account the disordered energy within the system. So you can easily say that G is a measure of energy within a system. It is a measure of ordered energy within a system. Now if the energy is in a disciplined form, if it is ordered, then what will happen? It can perform work. So G of any system, Gibbs energy of any system, gives you a message that it can do that amount of work. Now to have work from a system, this G must fall. If this is the initial state and this is the final state, and if the system comes from the initial to the final state, then we will have the change like this, that is del G equal to G final minus G initial. So it will be negative. Now why negative? It is very simple. You see this axis, in this direction G is increasing, and the final state is having a lower G, so the change will give you a negative value. The final has a lower value, initial has a higher value, and to have the change you have to subtract the initial from the final, so it will give you negative. Now see, this higher value of G is indicating that it can perform a greater amount of work compared to this one, since this is a measure of ordered energy. So more G means more ordered energy, less G means less ordered energy. So you have more ordered energy here, less ordered energy here. So where the difference has gone? Here you have more ordered energy, here you have less ordered energy. So the difference has been gained in the surrounding in the form of work. So that is the issue that was taken up by Helmholtz. Now this qualitative treatment is not acceptable. It will be better to have a quantitative relation, so that it is no more a belief system, rather than we get a concrete definition of the origin of this electrical work. So let us start. If we differentiate it, what we will get? It will be dH minus TdS minus SdT. Now you know it is the total heat content, enthalpy, so it will be D of U plus PV minus TdS minus SdT. Now it is du plus PdV plus VdP minus TdS minus SdT. Now we will measure the EMF of the galvanic cell keeping temperature and pressure constant. Our target is to measure the EMF. First let us make ourselves capable of measuring the EMF. Then we will tune the temperature. So presently we will restrict ourselves to constant temperature and pressure. Let us measure the EMF first. So dG at constant temperature pressure, it will be du plus pdv, so that will be 0. Differentiation of pressure and it is kept constant, so it will be 0. We will have TDS here, again this will be 0. So the equation reduces to this form. Now let us recall the first law of thermodynamics. First law of thermodynamics is given by this relation, d cross q equals to du plus d cross w. So you supply this amount of energy, thermal energy, which enters the system in the form of heat, and it produces this amount of internal energy change and it gives you work. Now what about this work? This is mechanical plus non-mechanical. You don't know whether your system will give you mechanical work or non-mechanical work. Now some of you have not heard of this term. You are actually accustomed to d cross w equals to pdv, that is the pressure volume work. So when there is a direct mass lifting in the surrounding, see this is a gas chamber and you supply thermal energy here, it enters in the form of heat and it increases the randomness of these molecules, temperature increases, internal energy increases and the internal pressure increases and it pulls the piston up and the piston gets pulled up along with its mass. So there is a mass lifting, weight lifting in the surrounding. So work is obtained in the surrounding. So that is a direct work. It is called the mechanical work and you can calculate it with the formula PdV. That is, P is the force per unit area and dV is the area into displacement. So area will cancel out and you will have force into displacement, so that will give you work. This is basically the concept. But what about this non-mechanical work? You must not ignore this. You can ignore this if someone inform you that there is no electrical work, that is non-mechanical work available from the system. So electrical work is the indirect form of work. It is referred as the non-mechanical work, since just by touching the wire to a fan or something, it is not going to rotate. You cannot get work just by touching the wire. You need a motor to convert that work to mechanical energy. Then the work will be observed. So this total work will be or better to be, it must be said, the total work must be depicted in this form, that is d cross w mechanical plus d cross w non-mechanical. So if there is no non-mechanical work, so you simply remove this. If there is no mechanical, you remove this, and if there are both, you account both of them. This is the issue. Now what about these cards? This is another problem. This is the ego problem of the state function. So you are writing a state function and path function in the form of an equation. Now for a state function, you can simply have the value of the change just by subtracting. You get the final result, you get the initial result, and if you subtract those two datas, final minus initial, it will give you the value of du, that is difference in the state function. Since a particular state is characterized by the particular value of this function. But what about this heat and work? These are path functions. These depend on which path you are going to the final state. If it is reversible, it will be associated with a different amount of work. If it is irreversible, it will be associated with a different amount of work, and there are many types of irreversible processes. You can cover it in one step, you can cover it in two steps. So it depends on the path. So for that purpose, you cannot have the value just by subtracting the final minus initial value. And there is nothing like, there is no property of a system like work. So system has this amount of work in the final state and this amount of work in the initial state, so subtract it and you will get the difference. So that must not be the procedure. You have to collect the information throughout the change. So for this rise, you get this amount of work, you take it. For the next rise, you get that amount of work, take it, write it, and just you add them up. And when you add all these, you will get this value. So the mode of getting the values are different. They are generically different. But you are writing in the same form. So how to distinguish? So have a cut mark. You have seen the Pirates of Caribbean, the movie. So when a pirate is getting released from jail, he is getting stamped in his left hand with a symbol P. So that branding indicates that be aware from that person. He is not a simple man or woman like you. He is a pirate. He or she is a pirate. So that is branding. Nothing else. No scientific issue. Now, I have told you just now that this d cross W mechanical is PdV. So you get du plus PdV plus d cross W non-mechanical, or you have du plus PdV equals to d cross Q minus d cross W non-mechanical. And you see, you have du plus PdV here and you have du plus PdV here. So put the value. So it will be d cross Q minus d cross W non-mechanical plus PdV minus TdS. Sorry, very sorry. You are putting the value of du plus PdV. So where from this another PdV coming from? This is a printing mistake. You see, when we replace the value of du plus PdV, we will get d cross Q minus d cross W non-mechanical. So this will not come. It will be simply minus TdS. Now we have the value of change in Gibbs free energy for a galvanic cell at constant temperature and pressure. Now if we draw electric current reversibly from this galvanic cell, let us see what will happen. So if the current is drawn reversibly, means you are switching on and switching off, and you are not continuing the current being drawn for a long time. Just you switch on the system and you switch off it. So you are taking the electrical energy, you are consuming the electrical energy in infinitesimally small amounts at a time, and not a large amount at a time, so that so that you are not allowing it to proceed irreversibly. Now for this equation will be modified by d cross q reversible minus d cross w non-mechanical reversible minus TdS. So you see one thing, this is the general equation and I am putting the reversible tagging only to this d cross q and d cross w and not to these expressions. Why? Because these two are state functions. It depends only on the initial and the final state, and in any way it is independent, of the nature of the path of transformation. So if you approach reversibly or irreversibly, that is going to affect only these two path functions and not these two state functions. So we are writing here reversible and reversible. Now what is the definition of change in entropy? It is the amount of heat change by temperature at which the change takes place. This is the definition of change in entropy, and we get it from the Carnot engine. You can remember from the second law of thermodynamics. So from this we can have d cross q reversible equals to TdS. Put the value. So it will be TdS minus d cross w non-mechanical reversible minus TdS. This will cancel. So you have or d cross w non-mechanical reversible equal to minus dg t comma p. So you get this. Now this is for the infinitesimal change. For finite change, what it will be? It will be w non-mechanical and reversible minus, this is for the finite change, t comma p. Now you get this. So this expression is telling you that the amount of electrical work, non-mechanical you see, mechanical has been cancelled in the course of this derivation. So the amount of electrical work, that is the non-mechanical work, that is obtained reversibly, obviously, is equal to the negative of the change in Gibbs free energy of the system at constant temperature and pressure for the galvanic cell. Now you cannot say that it is a belief. I believe it. I have made you. Now it is not in the state of belief. It is a quantitative relation, and using the thermodynamic principles I have derived it. So it is now clear that not enthalpy, not internal energy, nothing else other than the Gibbs free energy whose change is equal to the amount of electrical energy that you get from a galvanic cell. So if it is a quantitative relation, then obviously the qualitative relation is inbuilt within it. Now you see whether it is correct or not, just a check, formality. Gibbs free energy is decreasing from the initial to the final state. So del G will be negative. Now this one has a higher amount of ordered energy. So higher probability to perform work, and this has lower capability to perform work. So this is a highly disciplined system, and this has lesser amount of discipline. So what it will happen? The fall in Gibbs free energy is actually indicating that the work that can be achieved from the system is decreasing. So that will be only possible if it performs work. So only when this system performs work during the change, then only its capability to perform work will decrease. So orderness will decrease, disorderness will increase. So orderness is decreasing means ordered energy is being utilized. That's why the degree of orderness is decreasing. So you are getting work. Now this is the lower value. So if we subtract the higher value from the lower value, what we will get? We get negative. So del G negative implies we are getting work. Now see here, if we put del G negative, this negative will give you positive. So you will have a positive amount of work. So this is the message. Now in conclusion, we have the amount of electrical work that can be obtained from a galvanic cell reversibly is equal to the change in the Gibbs free energy of the reaction that is occurring in the galvanic cell under constant temperature and pressure. Now what about if the current is drawn irreversibly? What will then happen? If the current drawn is irreversibly, what will happen? So you have closed the circuit, system is switched on, and you are drawing the current rapidly. What will happen then? Now see this definition here. It will be d cross q irreversible by T. So this is the Clausius inequality. So the change in entropy is greater than this ratio. It is equal to this ratio when it is reversible, but it is greater than when this is irreversible. So if we put here, what you will get? It is d cross q irreversible less than T del S. It is d cross q irreversible less than TdS. Now what is our equation? It is dg t comma p, and it is d cross q reversible. So for irreversible it will be d cross q irreversible minus d cross w non-mechanical irreversible minus T del S. This is the general equation, and if you draw the current irreversibly, so the tagging will go to these path functions only. You will get d cross q irreversible here and d cross w non-mechanical irreversible. Now you have to put this in this equation. What you will do? You see, someone has given you this relation, that is y equals to 5 plus 4 equals to 9. Now you have an order that change this 5 by 6, but you know that this is the truth, y equals to 5 plus 4 equal to 9, and someone just without knowing anything about the system, he is just ordering you that change this 5 by 6. I want to see what happens. Now being a mathematician, what will you do? You have to follow the order. So you will write less than instead of equal to. That is the philosophy. So when we replace 5 by 6, the sum will give you 10, but y is not equal to 10. It is less than 10. So the only way to keep the order and also keeping the truth, not giving a false statement, is to bypass this by this inequation. So you have to, if you put here 6 instead of 5, you see this is the relation 5 less than 6. So you get y less than 6 plus 4. So here also in a similar way, if we put this inequation d cross q irreversible less than TdS, if we put TdS, what will happen? This will be less than. So you will get TdS minus d cross w non-mechanical, it is irreversible, minus TdS. So it will cancel out. Now we have dgt comma p less than minus d cross w, non-mechanical, irreversible. Now you see, if four is greater than minus 3, or better to be, if say, okay, 4 is greater than minus 3 and you have to multiply both sides by minus. So it will be minus 4 and it will be plus 3. What will be the sign? It is the truth that 4 is greater than minus 3. Now you are multiplying both sides by minus. So it will be minus 4 and it will be plus. Now what will be the sign? 3 is greater than minus 4. So in case of an inequation, if you multiply both sides by a negative sign, the greater than will be converted to less than, and vice versa. So you want this negative here, so you have to multiply the both sides by negative sign. So it will give us d cross w, non-mechanical, irreversible. You see, d cross w, non-mechanical, it is greater than, but it will be less than. We are writing this in the left hand side. Now it is greater than dg. When we multiply negative, it will be less than. So the less than sign will be towards the work done. So it will be minus dg t comma p. If you have any problem, just write it here for a time. So when you put minus here, it will be greater than here. So when you multiply both sides by negative, you get by minus 1, you get this relation. So I am writing this in this form. We are taking the right hand side and the left hand side. So this is the relation for the irreversible, and when infinite amount you get, it will be minus del g t comma p. So you see, when you draw the current irreversibly, what happens? You cannot access the maximum amount of work that is possible. So a galvanic cell is giving you electrical work from its chemical energy. Now it is the Gibbs free energy change of this galvanic cell that is giving you work. But when you draw the current reversibly, that is in small amounts every time, you get the maximum amount of work. And if you carry out the process irreversibly, that is, if you draw the current spontaneously, rapidly, it will give you less amount of work. See, for the state function, it is g is a state function, so this amount is fixed, the change is fixed. Now the work obtained is less than this value. Del g you get negative, you put here, it will be positive. So the work done will be less than this desired amount. And in this case, it will be equal to. So for the reversible process, you will get the maximum amount of work, and for the irreversible process, you get less amount of work. But to perform the math, we will consider the reversible process, since that is going to make our life simple, since this works with the equality. Now what about in practical life? Say you have a torch light and you have two dry cells within it. It is giving you current. Now you have to go to your farm to check the crops. Now if you know that you will get maximum amount of work if you draw the current reversibly, you are just switching on and off. You are making it off. A snake might bite you within the interval of darkness. So in reality, however, it is going to work. This is a hypothetical situation. But to compare the values, it is essential. To do the mathematics, it is essential. But in reality, this is more useful. So in reality, you cannot have the maximum amount of energy to be utilized. Now see, the topic given here, Nernst equation and determination of EMF is not covered in this lecture. So this I will claim as part 1 and stay with me for part 2, where I will give you the information about the Nernst equation and this topic. So let us continue.